Hi everyone, welcome to this video on lesson 2 of the Earth and Climate scheme of work. This lesson is about continental drift and really it's an introduction to the theory of plate tectonics, which is now the widely accepted theory of why we have lots of events on the Earth's surface, things like earthquakes and volcanoes and why mountains form and so on. But this is one of our historical case study lessons because what we want to do in this lesson is show to students that scientists haven't always thought about the Earth in that way. So we can start by explaining to them how scientists thought about why we have volcanoes and earthquakes and so on before Wegener. So what I'm going to do is draw the Earth here like this and show that what scientists thought originally, or not originally, but certainly before Wegener, is that the Earth was super hot. We don't need to go into loads of detail about that, but they had this idea that the Earth was hot, and that over time it was cooling, and therefore only very slightly, but noticeably nonetheless, it was therefore shrinking. So I'm showing the heat kind of escaping, the surroundings being heated. And the idea was that as the Earth was shrinking, it was cracking and all sorts of weird things were happening. And this is why we had earthquakes, we had volcanoes. This is how mountains formed as the shape of the Earth's surface changed. All of that seemed to be explained by this. And there wasn't exactly an explanation of why this would be the case, and no one had really made measurements at that time about the actual radius of the Earth and whether that was changing or not, but this is kind of what was believed. And that's all fine, and people were happy with that. But if that was the case, then what you can deduce from that is to say, well, okay, if this picture is true, then this current shape of the Earth that we have, so I'm going to just sketch this very roughly here like this. So if that's Britain and Ireland, and then sort of France, Spain, Italy, and so on, and then I can draw Africa below that. So this is a very rough sketch of Africa, but something like that. Then this shape of the Earth, I can do North America over here. So here's North America. If I go down here, here's South America. This shape of the Earth is never changed. So that's what you deduce if this theory was true, because the layout of the continents hasn't changed. All that's happening is that everything's shrinking. In fact, you could argue that all that would have happened is those have got closer together as time has gone on. But largely, apart from some changes to distance, the broad layout is unchanged. But this is what we can emphasize to students, is what Wegener noticed, and I'm sure he wasn't the first to notice, but he was certainly the first to put forward a substantive theory about this, is that, well, hang on, and again, my diagram is maybe not the best here. The diagram's helpful to lay it out in the guess, deduce, check format so that you can help students think about this and write about this, but definitely show them actual pictures, maps, and so on to illustrate this point. But what he noticed was, well, hang on, these two continents, especially Africa and South America, and really the whole of Europe, they look like they kind of fit together like the pieces of a jigsaw puzzle. So if that was true, that they fit together, maybe that implies that actually once upon a time they were together, and that therefore what would be true if the shrinking theory was true isn't quite correct. So it wasn't kind of conclusive evidence that proved the shrinking theory was wrong, but it certainly gave him some doubts. So I'm going to put a question mark in there like that. So Wegener had doubts. So what that meant was he needed a new model. He wasn't too sure about this model, so we needed a new one. So the model he came up with, and again, we take it for granted now, but it's kind of unbelievably radical, this model, because it changes our whole picture of the Earth structure. Wegener's model was as follows. So I'm going to draw two Earths this time, both the same size. And he said, actually, maybe the Earth never shrunk. Maybe that just isn't the case at all. Maybe, pardon me, once upon a time, all these continents were kind of together in this huge landmass, what we now call a supercontinent, called Pangaea. And that may be a word students have heard of. I know there's a brand called Pangaea, and it's probably used in all sorts of other kind of cultural references. And this is where it comes from. This is the supercontinent where all the continents were together. And he said, and again, by the way, it's helpful to draw this under the visualizer to show it in the guess deduce check, but definitely show them pictures. The internet has got much clearer pictures of this, which it's also worth showing to students as well. But what Wegener suggested was actually maybe once upon a time all of the continents were together, and that would explain this kind of jigsaw puzzle shape that we've got with, if I draw Africa here and South America, which looks like that. So maybe they were all together at some point, and what's happened since then, if I draw Africa, let's do Europe, so on. We can show where Britain is just to give them something like that. That maybe what's happened since then is that all the continents have therefore come apart. So if I then draw Brazil and going down to Chile and Argentina and so on, something like that, that actually what Wegener suggested was maybe the continents have slowly, over millions of years, been drifting apart. And this was his theory, which you may wish to label, or you may wish to just tell students, because they will be asked questions about it later. But he called this theory Continental Drift. This idea that the continents are drifting apart and have been doing for many millions of years. So this is super radical. This is crazy that actually the way we now look at the Earth, maybe it wasn't always like this. And what's even more crazy, and students in my experience find this really fascinating, is that this is still going on. And actually, and we'll come to this in the next lesson in more detail, but if this is true, what that implies is that the Atlantic Ocean is actually getting wider. The continents are still moving apart in that way. So let's think about what we could deduce from this. If this theory was true, well, what would we expect to see? And we can kind of explain to students that if you're going to put forward a model like this, you can't just say, yeah, I think all the continents were together, and base it off a really kind of, an intuition that, well, they look like they fit together, Africa and South America, so yeah, it's probably true. You've got to say, well, what sort of evidence should we look for? If that was true, what kind of things would I expect to observe? So what you can point out is three things that Wegener expected to observe. One is the rocks. So looking at rocks, we can get some evidence. And what he suggested was that the rocks in these different countries, or continents I should say, the kind of rocks you get should be similar on either side of the Atlantic. So yeah, the rocks over here, let's say, should be similar to the rocks over there. The rocks down here should be similar to the rocks here. And what it turns out is that the mountains in England, so the Pennines and so on, and this is hard to draw, but the mountains in England over here are actually very similar to the mountains on the east coast of the USA. They have very similar rock structures, as if they were once actually together. So in terms of our check, well, that seems to agree with Wegener's suggestion. The second thing he thought we should look for is fossils. If it's true that the continents were once all together, well, what we might expect then is that actually the kind of fossils we find on the west coast of Africa are kind of the same as the kind of fossils we might find on the east coast of South America. And there's lots of examples you can look up here, and there's a nice little video actually which is linked in the slides, but that talks about this theory of land bridges, and actually that doesn't really explain things very well. Basically, there's lots of evidence that you do get fossils fossil records matching on either side of the Atlantic Ocean. So this is another piece of evidence which suggests Wegener's theory is true. And then the final thing that you would expect, if this theory was true, is to do with the Earth's crust. And you would expect, if this was true, that the Earth's crust down the middle of the Atlantic Ocean would be newer than the Earth's crust at the sides, like this. Now, we're going to go into this in more detail in the next lesson on constricted plate boundaries, but at some point in the 20th century, I think it was the US Navy realized that you could look at the magnetic field that was kind of encoded a bit like a barcode into the seafloor, the crust on the seafloor in the Atlantic Ocean. And what they found was that actually kind of, because of the way the Earth's magnetic field flips every 300,000 years or so, that actually gave them a kind of dating system which they could use to understand how old different parts of the crust were. And essentially, they don't need to know loads about that, but they might find it interesting, and it's our job to share some of these ideas with them. But what scientists found was that the crust in the middle of the Atlantic Ocean is super new. Some of it is very recent in geological terms anyway, whereas the crust at the sides is much older. So actually this does, again, agree with what Wegener would have expected to happen if his theory of continental drift was true. So that's how I would go about explaining it, and what I hope is that by giving students this overview in terms of the guess-deduce check model, they can see how this idea has gone from being super radical, kind of crazy, to this idea that actually the map we have of the Earth hasn't always been the case, and actually the map is changing all the time. It's just very slowly, too slowly for us to detect. How that went from being a radical idea to being one that's widely accepted. And there's this quite poignant aspect to this lesson, which you can share with students, and I think it's really important for them to understand what science is, which is that Wegener was kind of ignored during his lifetime. People were like, who is this guy suggesting that all of the continents are once together? That's just mad. And he's got no evidence for it. And partly that's because he wasn't kind of part of the establishment, and what you can emphasize to students is that science doesn't always develop in this perfectly rational sense. Sometimes it takes a little bit of time for ideas to become accepted. So anyway, that is everything that we're going to cover in this lesson, and you'll see that there's lots and lots of questions about this that really prompt students to think in terms of the guess-deduce check model. We'll look at the seafloor spreading aspect of this and the constructive plate boundaries in more detail in the next lesson.